Welcome back everyone, I'm Paul Holloway, and on today's video we're going to talk about the difference between resolution and sensitivity. Resolution and sensitivity are two terms that come up a lot in ultrasonic testing. Now, resolution is the ability of the system, which is your flaw detector and your probe, to tell the difference between or resolve multiple closely spaced reflectors, whereas sensitivity is the ability of the system to detect really tiny reflectors. It can be a little bit difficult to try to envision how this all works, but it's not so difficult if we use digital photography as an analogy. Here we have some black dots on a white background, and we can use this to help us illustrate the effect of decreasing the resolution of the system. So in the first picture, the resolution is really high, so it's easy to tell the difference between the two dots on the bottom, even though they're basically touching. But as the resolution of our system decreases, the ability to tell the difference between those two closely spaced dots also decreases, until the point at which they kind of melt into each other. And if you keep going, the whole thing melts into kind of one blob. Now in ultrasound, as frequency goes up, so does resolution, and we can demonstrate that. This is a 2¼ meg probe and a 5 meg probe. So on the top of the screen, you'll see the 2¼ and you can see there's the top of a square notch. So I'm just looking at the top reflective surface, blends right into the back wall signal. So it would not be fair for me to say I can resolve that. But with the 5 meg probe, it's not a problem. Again, not surprising. As frequency goes up, so does resolution. Now we'll take a look at sensitivity. To demonstrate sensitivity with photography, I'm going to take you into my studio where I can turn the lights out. I'm going to show you that eye chart, and I'm going to change the ISO setting on the camera. Just like we did with resolution, we'll start at the top and we'll work our way down. So this is a high sensitivity setting of about 800. The picture is taken in almost total darkness in the studio. The door is propped open just a little bit, but at a high ISO setting, which is very sensitive, you can see the difference between the letters. You can see that there's even letters on the very bottom line. But as we decrease from 800 to 400, and to 200 and to 100 and eventually 50, you see that by the time we get down to the bottom, there's very little contrast left between the letters and the background color. And this would be analogous to having an A-scan signal on your screen, which is so close to the noise that you can't really tell if there's anything there at all. So ultrasonically for sensitivity, I can demonstrate the difference between the 2¼ and the 5 meg probe. If I put the 2¼ meg probe over this side-drilled hole at between about 55 to 60 millimeter sound path distance in this aluminum block, you can see I get the signal back to reference, but the noise level before is quite high. It's between about 3 and 5% screen height. By comparison, if I take the 5 megahertz probe, remember 5 megahertz has obviously a higher frequency, shorter wavelength. I'm in theory able to pick up smaller indications. Here you can see that I'm able to pick that hole up quite well, but still the noise level in front of the signal is quite low. So the sensitivity on the 5 meg is better, but that's not a big surprise since as frequency goes up, so does sensitivity. So we can talk about resolution and sensitivity on both sides, in UT and on digital photography. And I hope the tie-in between the two of them helps a little bit in trying to understand the differences. Thanks for watching the video and hope to see you next time.